Hello everyone, and welcome to lesson 4 of our square roots unit, a lesson on Pythagoras' theorem. Pythagoras' theorem gives us a special relationship between the lengths of the sides of a right triangle, and it's important to realize it only works for right triangles. And here is the relationship. If I have a right triangle, which means I have a 90-degree angle, one of the angles is 90 degrees, then the lengths of the sides are related like this. Sorry, that's 4. They're related in this relationship. 3 squared plus 4 squared equals 5 squared. And we can see that. 3 squared is 9, 4 squared is 16, and 5 squared is 25. So 9 plus 16 is 25. Now it's not necessarily these specific numbers. It's not necessarily 3, 4, and 5. 3, 4, and 5 is called a Pythagorean triple. The relationship is this regardless of the actual lengths. If you have a right triangle, the two legs are called A and B, and the side across from the right angle is called the hypotenuse. We'll call it C. And so the relationship is always the length of leg A squared plus the length of leg B squared equals the length of the hypotenuse squared. It's very important. It's the sum of the squares of the two legs that are equal to the square of the length of the hypotenuse. We use this a tremendous amount to find the unknown length of the side of a right triangle. As long as you're given the length of two of the sides, you can find the length of the third. Let's try a couple of examples. Here I've got a triangle, a right triangle, with legs of sides 6 and 8, and then an unknown hypotenuse. So I set up Pythagoras' theorem like this. The length of one leg squared plus the length of the other leg squared equals the length of the hypotenuse squared. And I can work that out. I get 36 plus 64 equals the hypotenuse squared. And so I get 100 equals the hypotenuse squared. And so the length of the hypotenuse would be 10. And we use it to solve for the unknown side. It isn't always the hypotenuse that's unknown, although here's another one where it's an unknown hypotenuse. Let's do this one together. You can see it's going to be 12 squared plus 5 squared equals the length of the hypotenuse squared. So I get 144 plus 25 equals the hypotenuse squared. And so I get 169 equals the hypotenuse squared. And so I hope you recognize that square root of 169 is 13. 13 equals the hypotenuse. You can see why this is in our square roots unit. We do a lot of square roots with it. Let's do another one. And here's one where I don't have the hypotenuse as the unknown. One of the legs is the unknown. We can still calculate that. In this case, we set it up in a similar way. X squared plus 12 squared equals 15 squared. And it's just our solving is a little bit different. You can see I've got x squared plus 144 equals 225. So now I'm going to get x squared equals 225 minus 144, which is 81. And so you can see if we square root 81, x is going to be 9. And so we've solved for the length of a leg rather than the length of a hypotenuse. So far, we've been working with side lengths that are called Pythagorean triples, as I said. And that's where we have three integers that satisfy the equation, satisfy the Pythagorean theorem. This isn't always the case. So if we have a triangle, a right triangle, something like this, with legs of 10 and 8, and an unknown hypotenuse, we can still solve to find the length of the hypotenuse. It would be 10 squared plus 8 squared equals the hypotenuse squared. And so I would get 164 equals the hypotenuse squared, and I simply use my calculator. I could do it, I could estimate it the way we were estimating before, but I think I'll use my calculator and do a square root of 164, and I get 12.8. So the length of that hypotenuse would be 12.8. Now here's a few to try on your own, and the answers will be on the notes sheet.